Hello, welcome friends. Me Anila. The topic of my discussion is about molar absorptivity. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to solve numericals on molar absorptivity. So, according to Lambert-Beer law, absorbance is directly proportional to path length and concentration. When a colored compound, the light passes on a colored compound, some amount of radiation is absorbed and some is transmitted. So we measure absorbance, and from that absorbance we measure transmittance. The amount of light absorbed, that is absorbance, is directly proportional to path length. If we increase path length, absorbance increases. Similarly, absorbance is also directly proportional to concentration. If we increase concentration, absorbance will increase. Example number 1. Standards 1 to 4 micromolar gives absorbances 0.12, 0.239, 0.476 in 1 centimeter cells. Unknown sample has absorbance 0.401. Find the concentration of unknown solution. So we have these in standards of known concentration. Standards are samples that have known concentration, the 1, 2 and 4 micromolar. For 1 micromolar, absorbance is 0.12, for 2 micromolar 0.239, for 4 micromolar it's 0.7476 in 1 centimeter cells. Unknown sample has absorbance 0.401. We have to find concentration of unknown solution. We know that this is the formula of Lambert-Beer law. A is equal to epsilon BC. A is absorbance. Epsilon is a constant molar absorptivity. B is path length and C is concentration. So epsilon is equal to absorbance over BC, A over BC. So first we will find molar absorptivity. E is equal to absorbance. We will write absorbance any one of them. So we will take first value 0.12 divided by path length 1 centimeter multiply and divide by 1 micromolar. We know that micro means exponent minus 6. So 1 exponent minus 6 molar. After solving, molar absorptivity is 12,000 molar inverse centimeter inverse. Now we have find the absorptivity. Now we will find out the concentration of unknown solution. We know that A is equal to epsilon BC. So C is equal to A over epsilon B. Now we will find the concentration of unknown solution. First we will write absorbance of unknown solution 0.401 divided by molar absorptivity value and divided by path length. After solving, concentration is found out to be 3.341 exponent minus 6 molar. This minus 6 we can replace it by micro because standards are given in micromolar, so we will write our answer in micromolar. So concentration is calculated to be 3.341 micromolar. Example number 2. A solution in a 1 centimeter cuvette has percent transmittance T is equal to 12 at a certain wavelength. If you put the same solution into a 3 centimeter cuvette, what will be the percent transmittance? So we have a solution in 1 centimeter cube. It has percent transmittance 12. And if we put the same solution in 3 centimeter cube, we have to find the percent transmittance. Solution. First, we will find out transmittance from percent transmittance. Percent transmittance is 12%. So, for determining the value of transmittance, 12 will be divided by 100. So, transmittance is calculated to be 0.12. Now, we know that A is equal to negative log of T. A is absorbance and T is transmittance. So we will place the value of transmittance in this formula. A is negative log 0.12. After taking log, answer appears minus 0.920. Negative 1 and negative become plus. So absorbance is calculated to be 0.920. Now we know that A is equal to EBC. Now we will put the value of A 0.920 is equal to epsilon into 1 centimeter into C. So in this equation there are two variables, epsilon and concentration. So epsilon is equal to 0.92 divided by C. So we have evaluated this relationship. Epsilon is equal to 0.92 over C. We know that A is equal to EBC. Now A is equal to, in place of epsilon we will write 0.92 over C, multiply, we will write path length 3 centimeter multiply by concentration. Concentration is cancelled. 0.92 multiplied by 3, answer appears 82.76. So this is the absorbance. Now we have to convert this absorbance into transmittance. We know that A is equal to negative log of 2. Put the value of A, 2.76 is equal to negative log of T. T is equal to log on other side is anti-log. T anti-log minus 2.76. Answer appears T is equal to 1.73 exponent minus 3. So transmittance, we have calculated transmittance. Now we have to convert it into percent transmittance. So we will multiply it by 100. So percent transmittance is 1.73 exponent minus 1, or we can say that percent transmittance is 0.173. So we have calculated percent transmittance of solution. Example number 3. You measure absorbance A is equal to 2.35 for a sample in 1 centimeter cube. Detector linear range is up to A is equal to 1.2. You dilute the sample 10 times and measure absorbance. A dilute is equal to 0.732. Molar absorptivity is 1.029 exponent 4. Find original concentration of solution. So in this example, first we will measure absorbance 2.35 in 1 centimeter cube, but the detector range is 1.2 and absorbance exceeds the limit. So we have to dilute the sample 10 times and then measure absorbance, which is 0.732. We can say it is absorbance of diluted solution. Molar absorptivity is given, path length is given, diluted absorbance is given. So we will put the formula. Solution. We know that A is equal to epsilon BC, A dilute. First we will calculate the concentration of dilute solution. So we will put value dilute 0.732, molar absorptivity 1.029 exponent 4 multiply by path length 1 centimeter multiply by C. After solving, concentration is calculated to be 7.11 exponent minus 5 molar. But this concentration is for diluted solution, and we have to find the original concentration that is for concentrated solution. So for 10 times concentrated, we will multiply it by exponent 1. So C is equal to 7.11 exponent minus 4 molar. So this is the original concentration of solution. In this way, we can calculate concentrations. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.